So as an example of that, let's look at problem 55 from your book. This is chapter 16. And this has a surfer who's looking at a water wave, and this water wave appears to be more or less sinusoidal, and they notice that the vertical distance from peak to crest, from peak to trough, is 0.45 meters. And then they further observe that the wavelength is 1.8 meters, so the distance from crest to crest. And then they observe for a little while, and they notice that 12 waves go by every 2 minutes. And so the question is, what function describes this based on the mathematics that we just talked about? This is our displacement, this is our position, and so we have this equation, which is the amplitude times the sine of kx minus omega t for a right-moving wave, plus this phase constant. Now, they didn't say anything about when we observe this wave, and so we don't really need to worry about the phase constant, so I'm just going to say this is equal to 0. You really only worry about the phase constant if you're comparing it to another wave. So we're just going to say that is the equation we need to worry about. So we need to find k, we need to find omega, and we need to find a. So our solution to this is, first let's start with a. So a, the amplitude, goes from the center of the wave to the crest or the trough. So our amplitude is just going to be 1/2 of that vertical distance. So we have that. So it's going to be what? 0.225 meters. Okay. For k, remember k is equal to 2 pi over lambda. Lambda is going to be the crest to crest distance. So we have 2 pi over 1.8 meters, which gives k has the units of radians per meter. So that works out okay. And then finally, we're going to have omega. We need to find omega, and omega is equal to 2 pi times the frequency. So the frequency, we know that there's 12 waves that go by every 2 minutes. So the frequency is going to be 12 waves every 2 minutes, which would be 6 waves per minute. But we typically write this in hertz, so we need this in seconds. So I say 1 minute is equal to 60 seconds. That 6 is going to cancel, and I'm going to get a frequency of 1/10 hertz. So that means this is 0.1 times 2 pi. So writing that in my equation, if I was going to write this down, I would say that's equal to 0.225 times the sine of 2 pi over 1.8 times x minus 0.1 times 2 pi times t. And that's something that we can now plot x or t and get the description of that wave.